Our Earth is dynamic, our landscape constantly changing, sometimes imperceptibly, sometimes dramatically. From the slow growth of mountains, measured in millimeters per year, to the rapid destruction of volcanoes and earthquakes, our Earth is never still. So, let's look at these features in more depth. Knowing where mountain ranges are located is important. The world's major mountain ranges are Rocky Mountains, Sierra Nevada, Appalachians, Andes, the Transantarctic Range, Atlas Mountains, Ethiopian Highlands, Drakensberg Range, Alps, Urals, Himalayas, Zagros Mountains, and Great Dividing Range. The 7 highest peaks in each continent are Mount Everest in Asia, Aconcagua in South America, Mount McKinley in North America, Kilimanjaro in Africa, Vincent Massif in Antarctica, Mount Elbrus in Europe, and Kosciuszko in Australia. In the United Kingdom, the highest peaks in each nation are Ben Nevis in Scotland, the highest at 1,344 metres, Snowdon in Wales at 1,085 metres, in England, Scafell Pike at a height of 987 metres, and Slieve Donard in Northern Ireland at 850 metres. So, we know where the significant mountains are located, but the question remains, how exactly are they formed? To understand how mountains are formed, we first need to take a closer look at the structure of the Earth. The Earth comprises of 4 main layers. The inner core is a solid ball of iron, with a temperature of 5,500 degrees Celsius. It is almost as hot as the surface of the Sun. Sharing a similar temperature, the outer core is a liquid layer composed of iron and nickel. Next, with a depth of 2,900 kilometers, the mantle is the thickest layer. The mantle is a viscous mix of semi-molten rock or magma, not quite a solid and not quite a liquid. The magma is also extremely hot. Finally, resting on top of the mantle is the crust. Composed of solid rock, the crust is the outer layer of the Earth's surface. Between 0 and 60 kilometers deep, it is the thinnest of all the layers. In terms of depth, think of the Earth's crust as the skin of a tomato, not the peel of an orange. It is in the crust that our mountains and other features of our landscape are formed. The Earth's crust is not one smooth, unbroken covering. Rather, it is made up of different sections called plates. There are 8 major plates: the Eurasian, African, Indo-Australian, Pacific, North American, South America, Nazca, and Antarctic. Some plates mark the boundaries of continents. Other plates include more than one politically defined continent. The Earth's plates are constantly moving. On average, this movement is between 1 and 10 centimeters each year. Within the mantle, heat rises and falls throughout the molten rocks. This causes convection currents. As the magma moves, so do the plates above. The movement of the Earth's plates and the changes this causes is called plate tectonics. The theory of plate tectonics explains how mountains are formed and why volcanoes and earthquakes occur. Plates can move in different ways. They can move towards each other or converge. They can move away from each other or diverge. Plates can also move in parallel along a transform boundary. As 2 plates move closer to each other, or converge, this creates intense pressure. This pressure can cause the plates to buckle in different ways. This process, over millions of years, can form a mountain. There are three main types of mountain: fold mountains, fault block mountains, and dome mountains. Fold mountains are the most common type of mountain. As two plates converge, the crust pushes upwards, forming the upwards folds, or anticlines, and the downwards folds, or synclines, of the mountain. Fold mountains are, geologically speaking, relatively young. For example, Mount Everest, among the other peaks of the Himalayan mountain range, was formed only 25 million years ago. Fault block mountains are also formed when two plates converge. Rather than the crust folding under the intense pressure of the moving plates, it cracks along lines of weakness called fault lines. The crust then breaks into a block, which is pushed upwards. The action of the wind and rain through the process of weathering and erosion will also help to shape the mountain. In some cases, the block in between the fault lines is pushed down to form a rift valley. Dome mountains are the result of molten rock from the mantle, pushing its way up under the Earth's crust. Without actually erupting onto the surface, the magma pushes up the overlaying layers of rock, which then bulge upwards. Eventually, the magma cools and becomes hardened rock. There are approximately 500 active volcanoes in the world. On average, 25 of these erupt each year. Volcanoes, like earthquakes, primarily occur on the boundary between two tectonic plates. Volcanoes are formed when magma penetrates through the Earth's crust. Some volcanoes are active, erupting regularly. Others are dormant and have not erupted in the recent past. Extinct volcanoes are dead and will not erupt again. At constructive plate boundaries, tectonic plates diverge or move apart from one another. As they move apart, molten rock rises or erupts from the mantle before cooling and hardening into solid rock. At destructive plate boundaries, tectonic plates move towards one another, or converge. As the plates meet, one plate is pushed underneath the other, lighter plate. The point at which the one plate is forced beneath the other is called the subduction zone. Friction causes the plate to melt, becoming molten magma. The magma then forces its way up the side of the plate boundary to form a volcano. One of the key features of a volcano is the magma chamber. From this, the magma rises through the pipe or central vent to the surface, forming lava. Eruptions take place through the crater and are accompanied by a toxic cloud of gas, ash, and rock particles, together called pyroclastic flow. Over many eruptions, layers of lava and ash build up, forming the flank of the volcano. Occasionally, branch pipes, sills, and parasitic cones are formed. The land around a volcano is rich in minerals, resulting in fertile soils, ideal for agriculture. But living in the vicinity of a volcano can be very dangerous. Every 30 seconds there is an earthquake somewhere in the world. Earthquakes are common at transform plate boundaries. As two tectonic plates move in parallel, friction causes them to stick. When they eventually become unstuck, it is often with a violent jolt. This jolt causes an earthquake. The focus of an earthquake is the point deep underground where the earthquake begins. When the earthquake is triggered, shock waves, called seismic waves, spread out in all directions from the focus. The epicenter is the point on the Earth's surface immediately above the focus. It is here that the earthquake is felt most strongly. Earthquakes have different strengths, or magnitudes. While some earthquakes are barely detectable, others can cause severe damage to property and result in terrible loss of life. The Richter scale measures the magnitude of an earthquake. Earthquakes with a magnitude of 3 are the smallest commonly felt by people, but cause no damage. With a magnitude of 4, an earthquake can make windows rattle, and there may be some minor breakages. With a magnitude of 6, there will be serious damage. Walls crack and split, and buildings can collapse. With a magnitude of 9, an earthquake is a severe, often catastrophic event. In theory, there is no upper limit to the Richter scale.